Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving a rational inequality algebraically. In our previous session, we have learned how to solve a rational inequality on a number line, and in our today's session, we will be learning how to solve a rational inequality algebraically. And in our previous session as well as in our today's session, we are having the other side. One side is having the rational expression and the other side is a 0. We are having the number 0 on the other side. Okay, and in our coming session, we will be solving another rational inequality, but over there we will be having some non-zero number on the other side. Okay. So without any further delay, let us start with today's session. Let us first of all look at the given question, the given inequality. The question is, find the solution set of x where x minus 1 over x plus 2 is less than or equal to 0. Now x minus 1 over x plus 2, this is the rational expression. A rational expression is always in the form of a fraction. There will be an algebraic expression in the numerator and another algebraic expression in the denominator. I'm saying algebraic expression, that doesn't mean that it should be a linear expression like we are having in this case. Instead of x minus 1, I can have x square minus 1 as well. Okay, so it will not always be a linear expression. Or else I can have a simple number. Instead of x minus 1, I can have 5, because 5 can be written as 5 times x to the power of 0. Okay, so any algebraic expression or the form of a fraction like this one is a rational expression. And now we come to the rules. Rule number 1 says, consider the two cases of the denominator being a positive and a negative number separately if it is not a perfect square. What is the meaning of if it is not a perfect square, and why do we need this? Actually, whenever we have a fraction, we usually try to get rid of the fraction form by trying to cancel the denominator. How do we cancel the denominator? We multiply both the sides by the denominator expression. But it is fine if it is an equation. It is also valid when it is an inequality, but we have to keep in mind that if we multiply or divide both sides of an inequality by a negative number, the inequality sign gets changed. That is where this if it is not a perfect square comes into picture. If x plus 2, instead of x plus 2, we had the expression as x plus 2 whole squared, then whatever may be the value of x, x can be a positive number, x can be a negative number, but x to the x plus 2 whole raised to the power of 2 will always be a positive number. So if we multiply both sides by x plus 2 raised to the power of 2, the inequality sign will not be changing. But in this case, in our case, it is not x plus 2 whole raised to the power of 2. Rather, we are having a simple x plus 2. And we do not know whether x plus 2 is a positive number or a negative number. So we have to take these two cases separately. When x plus 2 is a positive number and when x plus 2 is a negative number. You may be thinking, why not take the third possibility, x plus 2 equal to 0? Yes, of course, there is the third possibility. But we cannot have a 0 in the denominator, so x plus 2 cannot be equal to 0. Therefore, we exclude this third possibility and we take only the two possibilities. One is x plus 2 is greater than 0 and the other is x plus 2 is less than 0. Okay? So, let us take them one by one. Case 1, x plus 2 is greater than 0. That means x plus 2 is a positive number. This gives us the solution set as x is greater than negative 2. X can be any real number which is greater than -2. Okay. So now, since we know that x plus 2 is greater than 0, we will be getting rid of this denominator by multiplying both sides by this denominator expression. That is the rule number 2. That is what rule number 2 says. Multiply both sides by the denominator expression to get rid of the fraction. The inequality sign gets changed when the denominator is a negative number. But denominator in our case, in case 1, it is a positive number, so the inequality sign will not be changing. And we multiply both sides by x plus 2. And this x plus 2 in the denominator and the x plus 2 in the numerator will be cancelling each other. And 0 times x plus 2 is 0. So the inequality becomes x minus 1 is less than or equal to 0. And from this part, we get the solution set of x as x is less than or equal to positive 1. So x is greater than -2. This has to be taken because this is the case 1. X plus 2 is greater than 0. We have considered x plus 2 to be a positive number. That is why the inequality sign is not changing. So we cannot just ignore this part. X is greater than -2. And from here we are getting x is less than or equal to positive 1. Fair enough, because we can think of numbers which will be greater than -2 but will be less than or equal to 1. Suppose we take x to be equal to 0. 0 is greater than -2 but is less than 1. We may take 1. X equals 1. 1 is greater than -2 but is equal to 1. So there are real numbers which can be substituted for x, and they will be satisfying these two inequalities simultaneously. They will be greater than -2 but will be less than or equal to positive 1. So we can combine these two inequalities and we can write x is greater than -2 but is less than or equal to positive 1. Now coming to case number 2. Now x plus 2 is taken to be a negative number. So x plus 2 is less than 0, and this part gives the solution set of x as x is less than -2. And again we will be doing the same thing. We will be multiplying both sides by x plus 2, but in this case the inequality sign will be getting changed because we are multiplying by a negative number. So the less than or equal to gets converted to greater than or equal to, because this time x plus 2 is a negative number. Okay, and this x plus 2 in the denominator and this one in the numerator will be cancelling each other, and the inequality will be obviously 0 times x plus 2 is 0. So x minus 1 is greater than or equal to 0. And from here we are getting x solution set of x as x is greater than or equal to 1. So now we will be combining these two inequalities, these two solution sets of x. X is less than -2 and is greater than or equal to 1. Because these two are in the same case when x plus 2 is a negative number. X plus 2 is a negative number, gives the solution set of x as x is less than -2. And following this x plus 2 is a negative number, and from the given inequality we are getting this solution set of x as x is greater than or equal to 1. So we have to combine these two inequalities as well. So x is a real number which is greater than or equal to 1 and is less than -2. Okay. Rule number 3 says solve the inequalities from the two cases to find the final solution set. This is one of the solution set from case 1 and this is the other solution set of case 2. Now can you think of a number, a real number, which will be simultaneously greater than or equal to 1 and less than -2? At least I cannot think of any number which will be greater than or equal to 1 but will be less than -2. If you can think of any number, any real number, please write to me in the comment area. Okay. So we are seeing this is a valid inequality range, but this one is not. We do not have any number which simultaneously is greater than or equal to positive 1 and is less than negative 2. Therefore, the final solution, the final answer will be this one. X is greater than negative 2 and is less than or equal to positive 1. This is the solution set of this given inequality. Okay. So students, this is all for our today's session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.